fluid coding and AI here. Gemini 3.5 Flash is Google's new speed model, but the real question is not whether it is fast. The real question is whether it is ready to run useful agent work without surprising you on cost, limits, or reliability. Google introduced Gemini 3.5 on May 19, 2026, and started the family with Gemini 3.5 Flash. The pitch is bigger than cheap inference. Google describes it as a generally available, stable model for scaled production use, coding, long-horizon tasks, multimodal understanding, and agentic workflows. That is the headline. The tension is that launch claims are only the beginning. For developers, the useful question is whether the model behaves predictably inside real tools. Gemini 3.5 Flash is not hidden behind one developer preview. Google says it is available in the Gemini app, AI mode in search, Google Anti-Gravity, the Gemini API in AI Studio, Android Studio, Gemini Enterprise Agent Platform, and Gemini Enterprise. The Associated Press also reported the broader rollout, including the Gemini app and AI mode in search. So this launch matters beyond API users. Google is pushing one model family across consumer surfaces, developer tools, and enterprise agent products. The official API model ID is Gemini 3.5 Flash. Google lists it as generally available and stable. The model accepts text, images, audio, and video, and produces text. The DeepMind model card lists a context window up to 1 million tokens. For output, the docs and model card use slightly different wording, around 64 to 65,000 tokens, so the safe takeaway is simple. Long input, long text output, not media generation. That distinction matters. Multimodal input does not mean multimodal output. The biggest API change for builders may be thinking control. Gemini 3.5 Flash supports thinking levels: minimal, low, medium, and high. Google says the default move to medium, while high is meant for harder reasoning, math, and coding tasks. That gives developers a practical tuning surface. Start with medium, test low when latency or cost matters, and reserve high for work that actually needs deeper reasoning. Analysis, that is also a cost control strategy, because thinking can increase output token billing. The agent story is the center of the launch. Google points developers toward the newer Interactions API for agentic workflows and background tasks. It also describes anti-gravity as a development surface that can coordinate agents, scheduled tasks, command line work, SDK access, and integrations across Google developer platforms. Google also describes managed agents that can reason, use tools, and execute code in isolated Linux environments. That is the ambition, not one answer at a time, but model-driven work loops. Google's published numbers are strong, but they should be read as first-party benchmark claims. Google reports Terminal Bench 2.1 at 76.2%, MCP Atlas at 83.6%, Charxiv Reasoning at 84.2%, and GDPval LA at 1656 ELO. The DeepMind model card adds rows like SWE, Bench Pro Public, OS World Verified, Tulathlon, and MMMU Pro. Those numbers are useful signals. They are not a substitute for your own workload evaluation. Independent analysis sharpens the picture. Artificial analysis says Gemini 3.5 Flash sits on the intelligence versus speed Pareto frontier, scores 55 on its intelligence index, and reaches more than 280 output tokens per second. But there is a cost side. The same analysis says it is 5.5 times more costly to run on that index than Gemini 3 Flash, and 75% more costly than Gemini 3.1 Pro. Fast does not automatically mean cheap. The local OpenRouter benchmark report is the uncomfortable receipt. For Google/Gemini 3.5 Flash, the report shows 680 out of 2172 points, or 31.31% across the full suite. Every listed case is marked failed. The only non-zero credit came from coding tasks. Data interpretation, planning operations, quantitative reasoning, safety policy, source research, and writing editing all scored 0 in that run. That does not prove the model is bad. It proves this run failed and needs diagnosis. On Google's standard paid developer API pricing, Gemini 3.5 Flash is listed at $1.50 per 1 million input tokens and $9 per 1 million output tokens. Output pricing includes thinking tokens. Batch and Flex are cheaper, while priority inference is higher. The practical issue is not just the sticker price. Agent loops can create long prompts, tool traces, preserve thoughts, retries, and large outputs. If you use it for automation, measure tokens per completed task, not tokens per single answer. There are a few details developers should catch before wiring this into production. Google warns that function call responses must match the expected ID, name, and count, or the model may return empty responses. The docs also describe thought signatures that preserve reasoning context across turns, which can help multi-turn debugging and refactoring. But preserved context can add input tokens, and computer use is not supported in the Gemini API guide for this model, so do not market this as full desktop control by itself. Google says the model is generally available and stable, and it also says Gemini 3.5 was developed under its Frontier Safety Framework with strengthened cyber and CBRN safeguards. That matters, but agentic systems still need ordinary engineering discipline. Use retries, observability, evals, permission gates, and human approval for decisions with real consequences. Rate limits also vary by project and tier, across requests per minute, input tokens per minute, and requests per day. Capacity is part of the system design. Here is the practical verdict. Gemini 3.5 Flash is worth testing if you care about fast coding agents, long context workflows, tool use, or Google's agent ecosystem. It is also worth testing if your current model feels too slow for interactive developer loops. But do not adopt it from the launch deck alone. Run your own evals, include failure recovery, compare costs per completed task, and test the same workload through your actual provider path. The gap between official benchmarks and one failed OpenRouter run is exactly why local evaluation matters. If this helped you separate the launch story from the engineering reality, like the video and subscribe to Fluid Coding and AI. More model breakdowns, coding agent tests, and practical AI engineering workflows are coming next.